All right, so this is the chapter 4 study points. So basically, the biggest point of this chapter is to know the different bacteria, and like how different bacteria are either pathogenic, which means that they are deadly to, or not deadly, but harmful to humans, or non-pathogenic, which means that they're just like chilling in our body and they're not going to harm us. So we have to understand the abundance and the diversity of prokaryotes and the environment and their roles, contributions, and importance. So basically, prokaryotes are very, very abundant and they're everywhere. So there's like over like a 1 million species of prokaryotes, but only 6,000 have been classified and described, which basically proves to show that there are so many that we can't even begin to name all of them. And only 1 to 2% are pathogenic, which means that they cause disease. So that means that not all bacteria are inherently like harmful to us, because if all of them were harmful to us, we'd be dead right now. And they also aid in oxygen production, breaking down organic matter, and are part of many metabolic pathways. So we have to explain the various types of symbiotic relationships. So there's 5 of them: mutualism, amensalism, commensalism, neutralism, and parasitism. The biggest one you need to know is like parasitism, and I think amensalism are one of the ones that pop up in the quiz, but I'll go over all of them. So mutualism is where both benefits. Amensalism, only one is harmed and the other is unaffected. Commensalism, one benefits, the other is unaffected. Neutralism, both are unaffected. Parasitism, one benefits and the other is harmed. Know about the human microbiome. So there are a lot of diverse groups of bacteria in the body. So the ratio of bacteria cells is 10 to 1 human cell. So 10 for every 1 human cell, there's going to be 10 bacteria. And I think you do need to know this on the test as well. And they thrive in any cavity, any like wet, moist cavity. So like think mouth, your throat, your ears, your vagina, canal. And they also just thrive in moist areas of skin as well, but also some dry patches of skin as well. And it varies site to site and over time. They change over time. And then maintenance of the human microbiome. So basically, a lot of bacteria are important to the human homeostasis of different systems, like our digestive system, our reproductive system, and our epidermis system. You need to know what hemolysis is. So hemolysis is basically the complete breakdown of red blood cells. There is beta, alpha, and gamma. Beta is the complete breakdown of red blood cells. Alpha is the partial clearing of red blood cells. Gamma, no clearing of red blood cells. And blood agar plates basically are used to reveal whether bacteria is beta, alpha, or gamma hemolytic. And knowing this is just knowing like certain like characteristics of like a bacteria to better identify one. Distinguish between coliforms and non-coliforms. So coliforms are ferment lactose completely. Non-coliforms do not ferment lactose at all. Rhizobium, you do need to know this. This is a nitrogen-fixing ammonia bacteria. Nitrogen-fixing bacteria that produce ammonia for plants. Mycobacterium tuberculosis is the cause of TB. So they also have capsules, and since it's in that Mycobacterium family, you need to know that any Mycobacterium bacteria has mycolic acid, right? So if it has mycolic acid, you need to remember that it needs acid fast staining to determine like the cell morphology of the bacteria. Mycobacterium leprae, this also applies to this one as well. It also has a capsule, so it has is that like extra what's it called, armor around that bacteria. It is also the cause of leprosy. Corynebacterium, often harmless, but it is the genus for Corynebacterium diphtheria, which causes diphtheria. Diphtheriae that causes diphtheria. Clostridium botulinum, you need to know this one. So the most important practical application of Clostridium botulinum is that if you feed a baby raw honey, it will get sick and it will get botulism because usually this bacteria is found in raw honey or improperly canned goods. And it's also endospore forming as well. And since it's endospore forming, we know that it will usually start growing and thriving in these improperly canned goods where, bacteria or moisture or, air can get into that canned good and it can start growing. So that's why improperly canned goods usually have Clostridium botulinum and starts growing. Clostridium perfringens, it causes grass gangrene. You need to know that one. Clostridium tetani causes tetanus, produces toxin, and is a tennis racket shape. Clostridium difficile, you need to know this one. C. diff. So C. diff is an endospore former, and it's very, very important in hospital settings because it's difficult to remove in hospitals due to its spores, right? So if you think you got rid of all evidence or traces of C. diff, right, since it is an endospore former, endospores, they basically make the bacteria go into hibernation until it is in the optimal environment to grow again, right? So you might think that you got rid of C. diff in your hospital, but once the conditions are right, it can start growing again, and you can see basically a rise in C. diff in your patients. Streptococcus. So streptococcus, normal. Some of them are usually part of your normal microbiota, or some can cause infectious disease in humans, and these can lyse cells. So Streptococcus pyogenes causes strep throat, beta hemolytic, necrotizing fasciitis. Streptococcus pneumoniae at alpha hemolytic. It's usually encapsulated, which protects it from the immune system, can cause meningitis, endocarditis, and etc. Lactobacillus, you need to know that this one is an aerotolerant anaerobe, which means that it can tolerate oxygen, but prefers no oxygen. So basically it means that it can tolerate some oxygen in the air, but if the oxygen levels are lower, that's when it can thrive and grow more. And it is also fermentative. So it's not killed by oxygen, like I said before, because it can tolerate it. And it produces is a product of fermentation and can be used as a probiotic. So bacillus, gram-positive, endospore former, some sorts of antibiotics. So think of Bacillus anthracis and Bacillus cereus. Bacillus cereus causes food poisoning in spoiled milk. Former Bacillus anthracis, you need to know this one. So Bacillus anthracis is also the cause of anthrax, but Staphylococcus aureus is very important because Staphylococcus has many different antibiotic resistant strains. And some of the more important strains to know of is like MRSA strains. So if you ever heard of MRSA is a very, very, very big problem in hospitals because since it is resistant, there's so many different strains that are resistant to antibiotics. It's hard to treat MRSA patients because it's hard to find antibiotics that can kill MRSA strains. Since it is beta-lactam resistant, basically just means that antibiotics that can't target specific targets in bacteria, if that makes sense. Just know that very bad. Staphylococcus epidermidis. So it's a gram-positive cocci, rarely pathogenic, usually part of the human microbiota on the skin. Pseudomonas diverse, produce biofilm, infections caused in different regions, eyes, ears, and lungs. Vibrio cholerae causes cholera, found in water and contaminated seafood. Legionella pneumophila. You don't really need to know that one. E. coli. So it's basically found in intestinal tract and is used as an identifier for fecal contamination. So if you ever remember like lettuce, like E. coli being found in like Chipotle lettuce, basically means that, oh, there's like fecal on your fecal contamination on your lettuce. Pretty bad, can make you sick. Salmonella, many species related to food poisoning, typhoid fever. Yeah, that's it.